Hello everyone, welcome to another show of New Hampshire Citizens for Progress. The show is going to be on generating power from your water supply, whether it's clean or dirty water. What does that mean? Do you turn on your sink? Does water run? Do you flush your toilet? Does water go down the drain? Well, we have a possibility to generate electricity from water. And we brought a gentleman that has a company that specializes in this. And Frank, you want to briefly introduce yourself?
Yeah, hi Rick. Thanks for having me on today. I'm Frank Samatero. I'm the CEO and co-founder of a company in New York City called Rentricity. And we recover energy from drinking water systems. What I thought I would do is just tell you a little about how we do this. But first, did you know that we move over 400 billion gallons of water through pipes every single day in this country? And about 75% of that is gravity fed, meaning there's all this excess pressure that needs to be dissipated before it gets to you at home. We used to use traditional technologies to do this, but now today we have smaller micro turbine technologies that allow potable or drinking water operators to install them. So Rick is exactly right. When you turn on your water or use water at your home, you are potentially providing the basis for creating energy recovery right in your water system. What I'm going to do is show a brief video and allow you to see how this actually works. And then we're going to talk about an example of a project that we've done in Keene, New Hampshire. So we have this building that has these pressure regulator valves, and we install a turbine generator which performs the same function of that valve, but it spins a wheel or an impeller and makes clean electricity. And we do this within vaults that are under the ground or above the ground, which you don't typically see because water infrastructure is hidden. So basically, Rentricity works with drinking water companies to design systems to recover energy where valves are normally placed to regulate that water flow and pressure before it gets to your home. And the company has been doing this since 2012 commercially and has 15 sites in the United States and one in Canada. And these turbine generators are now smaller and more modular and can be fit within the vaults and the infrastructure that is right under the ground on the edge of the street. Basically, it is hydropower at a micro or pico level. And we'll show this video again right now.
Hey, good morning. Rentricity. Did you know that there's 400 billion gallons of water that flows through pipes every day? And a lot of that water is actually depressurized with valves. Rentricity deploys reverse pumps as turbines to collect that excess pressure and flow and create electricity. We take that power, we put it on the grid, or we interconnect it to a local pump station or a water treatment facility. We also have the ability to power up sensors and other water quality devices to make the water grid much smarter as well. We've done this before. Our City of Keene project is the most notable. It is the first energy-neutral water treatment plant in the world powered by its own inflow of water.
What you're seeing is a typical vault that's above ground, in this example, with all of the pipes and valves that are typically inside it. We install a turbine generator around that valve to perform the same function, but to capture that wasted energy that's dissipated by that valve and make a clean form of electricity which could be transported to the electric grid. Okay, Keene is a city of about 24 1,000 people, and it has I believe, a university and a college both in there. And in 2012, Keene was very interested in exploring the use of a microturbine to improve their sustainability objectives and clean energy objectives. They contacted Rentricity, who provided the basis for doing engineering of their 3 million gallon a day system, which delivers water from a high elevation to a low elevation, and then brings it into their water treatment plant. They deploy a regulator valve at the inlet of this plant, which dissipates the pressure. There's also a flow variation of between 700 gallons a minute and 2,100 gallons a minute. So ultimately, we designed a dual microturbine installation to perform the same function of that valve, where when it's low flow, the small turbine is on. When it's medium flow, the bigger turbine is on. And when it's high flow, both turbines are on. And ultimately, the Keene installation and turbine generators make this entire water treatment plant energy neutral, powered by its own inflow of water into the plant. Keene transports all of this electricity to the Public Service of New Hampshire and enjoys the benefit of a net zero energy water treatment plant, and has been operating it now successfully since 2012. The entity, or Keene, has been able to save approximately $25,000 a year in electricity costs, and then get some additional benefits from Public Service New Hampshire, and will in fact save over $1 million over the 30-year life of this equipment. So they are enjoying providing this capability to the drinking water users of Keene, and running their water utility in an energy efficient manner.
So if I was to try to make this really understandable by most people, is that in conditions where we have a tank that's elevated, that's either delivering clean water or treatment water to a treatment plant, we have gravity because of that. Now at this point there, if you design the system so it takes energy recovery into the equation in the design factor, because I've tried to talk to water departments and they kind of say, well, we have zero gain, there's no head. We designed the system to be perfect the way it is. So would it be fair to me to say that this works best in new situations, being a new water supply or storage tanks, or in an update of the water system that would be the most beneficial for them to pursue this type of system?
Well, it's a great question, and there are really two main points here. Our water systems have evolved in the United States over the past 150 years, from hollowed out cedar pipes to the ductile iron pipes that we use today. And in some cases, the incremental additions and growth and urban sprawl have created inefficiencies in the design of those water systems. Therefore, valves are deployed to regulate pressure. So that is an inherent inefficiency in some systems. And you are absolutely correct. There have been some master plans around cities where they don't use any pressure regulator or flow control valves because they have fine-tuned it from the get-go. So you're exactly right. This won't work in every system, only where there's an inherent inefficiency over a long-term evolution. But there's a great opportunity here. Moving forward, as we rebuild our infrastructure, and specifically our water infrastructure, we have an opportunity to look at our plans to put in new pipes and new valves and vaults to serve current populations and new populations that may be growing. And we have the opportunity to make that infrastructure energy recovery ready. We have the ability to make that infrastructure smart and sustainable. So there is an opportunity to add energy recovery into the strategic planning process of evolving our water systems moving forward. And as consumers and as ratepayers, you have the right to ask those questions to your water utility managers about how are we going to evolve this so that we're being more energy efficient? And is there an opportunity to look at pipes and valves and plans around the engineering of upgrades to consider this as an innovation for more sustainability and obviously reducing our reliance on fossil fuel? That's right. And the earlier in the design cycle, with the engineers of record of cities in the state of New Hampshire, is when you want to bring up these questions. So typically, cities will look at creating a 5-year plan on the upgrade of their infrastructure. There may be an opportunity as part of that planning activity to consider this as an add-on to that upgrade. So it is clear that the planning sessions, long-term planning sessions, this has to play a role, and it has to be in the discussion. And then there may in fact be an emergency where there's a valve or a main that has broken and there's an emergency repair. Well, guess what? If you're going to just go out and buy some pipe and buy a new valve, you might have the opportunity to also make that vault a little larger so it can be energy recovery ready and can eventually include a turbine in the future. So there's a number of strategic and tactical steps that water operators can take to evolve the system in a logical, incremental way.
So when they take and they make it a design criteria to have energy recovery, there was funding available via the EPA to support such changes. Is that still true today, or has that changed?
No, in fact, the EPA has something called the State Revolving Fund Program. It's a very low interest rate program for water utility infrastructure upgrades. It now includes energy efficiency enhancements as part of that program. So a water operator who is seeking additional support from the federal government, specifically the EPA and the State Revolving Fund Program, for an upgrade of this type, adding a microturbine in addition to the valving and piping to recover energy from the high pressure moving water. Yes.
So in regards to Keene, where this was the dirty water, this was the storage of the water that needed to be treated by the water treatment facility. And having a tank and a gravity feed is pretty much standard for that type of operation, unless you don't have any elevation changes and you have to use motors to accomplish it. So in New Hampshire, we're not in the flatlands. So most of our dirty water treatment systems should be able to find a way to make your system and energy recovery a criteria, a policy, and a reality.
Well, it all comes down to the source water location. It's highly elevated surface water reservoir, natural waterway, that's delivering a raw water feed to a water treatment plant down below, lower elevation. Clearly an opportunity. If the source water is out of a river and is
pumped out into the water treatment plant. There's probably no opportunity at the water treatment plant. However, as that water is distributed across the network of pipes that are under the ground, that water would be pumped to the top of a hill, but as that water descends to the population at the bottom of the hill, there's likely a valve deployed at the bottom. So there are opportunities at the inlet of water treatment plants. There are opportunities within the distribution system where valves are deployed to regulate pressure. And there may be locations where tanks, ground storage tanks, those large round metal tanks that you see driving around sometimes they use those valves to regulate the flow into those tanks as well. There are a number of locations within drinking water systems that could be explored depending upon surface water location, the elevation difference, and the various use of valves and flow control valves to regulate that flow and pressure.
So in particular in regards to the city of Manchester, I know the north end of the city on the opposite side of the Merrimack River here, up towards Bass Outfitters, I believe is the location in Hooksett. They're taking and putting a new water system for that end of town. So what they're doing is they're running, I believe they called it a louver system underneath the river, 20 to 30 feet into the sand beneath the Merrimack River, where they'll be drawing 80-20, 80 from the existing water below the river, not affecting the river itself, and possibly 20% of river water. And the quality of the water is really high, so they're going to be pumping that up to a tank. Even though the water quality is really high, it still has to be treated prior to going into the delivery to distribution system for people to use in their homes. This is, I think, in the still design phase. It hasn't been physically started yet. It may have been a contracts awarded, I'm not sure. But that would sound like the ideal location that's being a new project being built. It's going to be gravity fed from the storage unit to the treatment system. And that if they had this in mind, and I think this is a real key point, the design criteria has to include energy recovery.
I think you're right. If there is in fact an elevation difference between that ground storage tank and the treatment facility, there may be enough head or pressure that's created by that downhill flow to support the use of a turbine generator. And what's actually good about the location is that at the inlet of the treatment plant, that energy may be able to be used all behind the meter right there on site. It doesn't even have to be transported to the grid, which actually reduces cost. So you're right. At the drawing board stage of a project of that type, an energy recovery audit can be performed looking at the existing engineering drawings, and recommendations can be made. Again, it all comes down to the amount of flow and the amount of head or elevation difference between the source water or the tank water and where you would locate that turbine generator to collect that excess energy and make clean electricity.
Well, it made an interesting point there where what we have is, you said before the meter. So that's all the pumps, all the electricity that would be used in that building because they're generating the power at the same location can be used there. And then only the excess. Now this would require net metering, a way to monitor how much extra energy you put into the power supply and how much you took out. And New Hampshire's not too bad on their net metering, it's a little light. They're only at 1 meg. So it limits the size of the systems and the amount of recovery, especially if you're not at a location that is near where the electricity is going to be used. Because you're mentioning distribution system and different valve locations which don't match where the city would be using electricity. So the only way they have to address that is some means of getting it net metering, getting it into the grid, available to other people. That way the city puts some in, usually at wholesale, and then when they draw it out, typically at retail. But they get to pull it from different, where they need it, as opposed to where it's being generated.
Yeah, and you raise a real interesting point. The electric infrastructure that is in our country, mainly in, out of the city, big city centers, and water infrastructure share the same physical space. 10 feet in from that street, that 10-foot right of way, above ground you have high voltage electricity lines, below ground of water lines. And marrying those two infrastructures by using these kinds of technologies is a very interesting opportunity. So you raise a very, very good point, and clearly net metering regulations in New England, generally speaking, are above average, and they are very, very open to these forms of technology to allow more green electrons onto the grid. So we saw that at Public Service of New Hampshire with the Keene project, and I think they're enjoying the benefits of net metering.
Well, there appears to me that there might be one other way you could use this power, is that I know for a fact they're paying the water department to run a diesel generator during peak period, which is something they only normally ran the generator for maintenance purposes, to make sure it ran and it had so much runtime every so many months.
By participating in this utility load reduction program, we are going to lower our peak by being off the grid at the peak times. Additionally, Keith is keeping an eye on that type of stuff and will be advising us when peak demand occurrences are. So we're going to do everything we can to be as small a profile as we can be during those off times. And that, according to C-Power's estimates, and Keith confirmed it because I ran all these things through him, is another $385,268 in potential savings over the 5 years. So in totality, we should bring back about $800,000 by participating in these new programs. In exchange,
that it almost sounds like this could be a type of storage solution of power, where you have an elevated tank. During non-peak period, you use the electric pumps to fill that tank. Now, as opposed to running a diesel, dirty engine to generate power, that elevated tank could in fact generate power during the peak period. Pump it up during low peak, let it empty, and run a generator, turbines, during peak period. And it seems that we eliminate the carbon and the use of dirty fuels and mining and all that stuff.
Yeah, the program you allude to is called demand response programs, where the electric utilities provide these diesel generators to water utilities to be in standby mode in case of brownout, blackout situations. And clearly it offers a benefit to the water utilities to be able to keep running or pushing water, albeit it is running diesel, so it is running a fossil fuel. So you can explore the use of creating a green demand response with water turbines, but they would have to be available. That head and pressure would have to be available. And so again, it's a very good thought, and it could certainly provide a solution in that regard. However, there are other potential uses, especially in and around resiliency events like Hurricane Sandy, where certain centralized distribution water treatment plants can't get out all of that chlorination to the end parts of the system when there is an event like that. So deploying water turbines out further into the distribution network, potentially just to power up UV disinfection, could offer a lot of value during those kinds of events. So there are some areas to explore in that regard.
Well, Frank, we're running out of time here. I want to make sure that everything gets covered that we needed. I thank you very much for joining us, and I look forward to talking to you soon. And for all of you at home that watched this show, I hope you enjoyed it. Be well, be healthy, be safe. Take care. Thank you.
Don't you know you're talking about a revolution? It sounds like a whisper. Don't you know they're talking about a revolution?
The preceding program was provided by an independent producer solely responsible for its content. The opinions expressed do not necessarily represent the views of this station, its staff, board of directors, or underwriters.